Hello and welcome. This is Dr. Harrista here. In this video, I will present to you first half of chapter 3. The first half of chapter 3 deals with measures of central tendency. As you know, there are two distinct branches of statistics. We talked about those in week 1. The descriptive statistics and inferential statistics. Chapter 3 talks about descriptive statistics. And as you know, descriptive statistics is the science of collecting, organizing, analyzing, and presenting data on its face value without making any judgments or without making any assumptions or estimations. Descriptive statistics then has two further types. There are measures of central tendency or measures of location, and there are measures of dispersion. The measures of central tendency or measures of location find out where certain locations are. The most widely used statistic in the world is mean. Mean is also referred to as average, and that is the center point of the data that is acquired by adding all the values and then dividing them by how many they are. Median is another center point of the data. So in statistics, we have two center points of the data, two types of center points, the mean and the median. And the mode is basically the most repeated observation in the data. So we're going to talk about all these different measures. The mean or the average is the most widely used statistic. And it's simply calculated by adding all the values and dividing them by how many they are. Here's the formula for mean. And this is the formula for sample mean. And the formula states that x bar, which is the notation for the sample mean, equals to the sum of all observations, where each observation is referred to as x. And you see a summation sign that sums up 1 through n, all of the different observations that are out there, and then divides it by n, and that is how many number of observations we have. The population mean, there is only a difference of notation, and the notation changes to this sign, and this is read as mu. So mu equals summation x over n. Summation x means that you sum up all the observations in the data, and then n is how many they are and divided by how many they are, and that gives you the mean. So this is a simple example. You have 5 observations, 6.2, 7.1, 4.8, 9.0, and 3.3. If you wanted to find out the mean, the summation 1 through n of all the values that are x or observations, you would add all of these values together. So 6.2 plus 7.1 plus 4.8 plus 9.0 plus 3.3. And since you have 5 values, you would divide them by 5. And you get a mean, which is 6.08. Supposedly this mean is the center point of the data. We will find out that there are certain problems in making that statement. So let's take a look at the advantages and disadvantages of the mean, first of all. Well, the mean is very simple to calculate. It's a very simple concept. It summarizes the data with a single value, so kind of gives you the average in one value, the middle. The disadvantages are, the biggest disadvantage of mean is that it is sensitive to the outliers or the extreme values. So if you have extreme values on the upper side or the lower side, then the mean is skewed. It's not accurate. And then it doesn't give you the full representation of the data, it's just one number. The median is also the midpoint of the data. And this midpoint you get after you have organized all the values in an ascending order. You pick the middle value. So the formula for the mean is that the mean is 0.5 times n, where n is the number of observations. So if you have odd number of observations, the median calculation is very easy. You can, let's say for example, if you have 13 observations, you can have 6 on one side and 6 on the other after you have organized the values in an ascending order, and then you pick the middle value. If you have even number of observations, you can average the two middle values. So here's an example of the median. You have these numbers, 21, 27, 27, 28, 34, 45, and 50. Total 7 of them. And the midpoint of the data is 0.5 times n, or half of n, which is 3.5. So you would round it up to the whole number and you get the 4. So the fourth value after the data has been organized in an ascending order is the median. So if you organize the data in an ascending order, you get 21, 27, 27, 28, 34, 45, and 50. Now these values have been organized in an ascending order. The fourth value is the median, so which is 28. So unlike mean, the median is not sensitive to the extreme values because it organizes the data in an ascending order and picks one value that usually is a representative value of the data. So the drawback of mean is not a drawback of median. So where you cannot use mean, you can use the median. If it's an even number of data values, you would divide that after organizing them in an ascending order, you would divide them and pick the two middle values and average the two together. So in this example, you have 6 values. We organize the values in an ascending order. The third value and fourth value are added together and divided by 2 in order to get the median. Mode is a value that appears most number of times. So it's the most popular value in the data. So consider this data set. 2 is repeated most number of times, which is 8 times in this data set. Therefore, the mode is 2. So if the data is categorical data, the mode is significant if you're counting different colors or different objects, which object or which color is most popular. So in this one data set, house prices, you have a house that's $2 million, and then you have 500,000, 300,000, and two houses that are 100,000 each. You definitely see an outlier, which is 2 million, and therefore the mean is skewed. And that $2 million number is taking the mean up to 600,000, which is not reflective of the data. The median picks the middle value, and as you can see, these are 5 values, and they're already organized in ascending order: 100, 100,000, 100,000, and then 300 and 500 and 2 million. So if you take the 5 and multiply it with 0.5, you get 2.5. You round it up to the third number. So the third number in an organized fashion would be the median. So therefore, the third value after you organize the data in an ascending order, which is 100,000, 100,000, 300,000, 500,000, and 2 million, the median is 300,000. Somewhat of a better representative of the data than the mean in this case. The mode is a value that appears the most number of times. In this case, 100,000 appeared twice, so that's mode. If no value appears more than once or higher than other values, then the mode would be not applicable. So as far as the shape of the distributions is concerned, the symmetric and skewed are the two different types of shapes. It can be left skewed, where mean is less than the median, or right skewed, where mean is more than the median, or the median is less than the mean. So the mean is used where there are no extreme values or outliers. If you see outliers, then you would use the median. In categorical data, we make use of the mode. So in the end of this presentation, let me review some of the advantages and disadvantages of the 3 measures that we studied in this video. First half of chapter 3. We talked about mean, median, and mode. Mean is easy to calculate and easy to understand. It's the most widely used statistic. The disadvantage is that it is affected by unusually large and unusually small values. The disadvantage of mean, it becomes the advantage of the median, which is not affected by extreme values. And median, the problem is that it requires more effort, but in the days of computer, it really doesn't. You just plug things in and you get your answers. Mode is used for categorical data, and if the data is not categorical, it's not that much of a use. So in this video, we talked about first half of chapter 3, which talks about half of descriptive statistics. Descriptive statistics is the science of collecting, analyzing, organizing, and presenting data to make more informed decisions without making any estimations or judgments about the data. And in descriptive statistics, we have measures of location and measures of dispersion. Measures of location or central tendency tell you where certain points are in the data, or for example, where is the middle of the data. We talked about the mean, the median, and the mode.